Hello, this is Brian Hegney, instructor of game design here at High Point University. This next video, we've moved a door, and this time we are finally going to actually be able to animate it a little nicer, right? We're not just going to teleport it, we are going to make it move in a wonderful way. So let's go ahead and do that. In order to do that, we're going to learn about a nifty new component of our blueprint, and that is going to be a timeline. Okay, so we're still going to set the relative location of this door, but we are not going to tell it what location to do. We actually are going to create, but we're not going to type it in here, right? We're going to have actually an animation that will go from one place to another place. Okay, so how do we do that? Let's go ahead and talk about the term linear interpolation. So linear interpolation is going to be interpolating from one value to another value. In this case, it's going to be the value of a vector. And remember, a vector is a variable. It's a variable with three different values to it. So x, y, z, RGB. Those two are both vectors. What I'm going to do is drag off from new location. And I'm going to say, type in lerp. And notice that because context sensitive is turned on, there's only one option for this particular, from this node, because it's a vector node. Now, if I were to left click off of that and right click and type in lerp, you'll see we can do a linear color lerp, a rotator lerp, transform lerp. So we can linearly interpolate between many different types of values. Okay, all right. Let's drag off from new location, type in lerp, and accept the vector lerp. Yay. Now, this looks a little crazy. What I could do is say, you know what, I'm going to linearly interpolate from A to B. A to B. And yeah. And that value is going to be, let's type in that, the value would be 00200 as the starting value, and the ending value is 00700. Remember that? So what we want to do is linearly interpolate between these two values. And alpha, we'll deal with alpha in a minute. Now, this isn't going to do anything yet, so we are not going to do much to it. What we need to do is have a driver for this alpha. Just to show you, if I leave this at 0, I will do something. I'm going to show you what this alpha means. So that's 0 right now. When I come in here, nothing happens. If I set that alpha to 1, compile that, it raises that door up to where it should have been. Okay. Now, what if I set this alpha to be 0.25? How about 0.05? Nope, 0.1. If that alpha is set to 0.1, it should only go 1/10 of the way up. See? 1/10. Okay, so this alpha will tell it at what point does it go through. So if I actually set alpha to 0.5, it's going to go halfway between 200 and 700 in the z value, which is half of 500. That's 250. So that would go up to 450, sorry. And we can see that. So we'll go halfway up than it should. Okay, so now that you understand what that alpha does, like what does it do? What we're going to do is animate it, right? Because it's not an animation yet. And we're going to drag this from the branch, from the true branch, and we're going to let go and type in the word timeline. Timeline. And there's something called add timeline. And it is a node, it's a function, and we are going to call it, let's say door open. Open door. How about this? No door open? Open door. Okay. Now, when we open the door, we could do a bunch of things. Like, what if the door rotates when it raises up? What if the door shakes? What if the door does other things? Inside of this timeline, we're going to have the option to create a number of different types of animation drivers, but the first one we want to do is raising the door, okay? So I'm going to double click into here. When you double click the timeline, all it does is open a new graph or a new tab. If I go into the event graph again, I'll still see it here, and double clicking it just opened up this tab up here. I could close this timeline tab. I can always go back to it. Now there's nothing here to start with. So the thing I'm going to do is click on the add a float track. And the first thing we can do is make a name. So I'm going to say raise door. That's what I'm going to call it. If you made a mistake and you just hit enter, you can always select that raise door or right click and say rename. And I can rename it to something else. But I want raise door. Okay. Raise door's already in use. Okay, fine. Then I'm just going to click off of it. Now, this is a line. This is a timeline. Right now, the length is 5. That means 5 seconds. How long should we raise the door for? Probably 1 second tops. So I'm going to say the length should be 1. I am going to shift click in here. So right now this value is at 0 and it's going to stay 0 for 1 second. Well, I want to change the value over time. So by shift clicking, I'm going to add nodes, and I only want to add 2 nodes. I can move these around using the interface here, or I could say left click up here for the time and the value for each selected node. And I can select the node by left clicking it or left clicking and dragging. This node is going to start at time 0, and its value is going to be 0. This node is going to be time at 1, and its value is going to be 1. Oop, where did it go? I have to click these little extend zoom extents buttons to see them totally. There we go. That's all we're going to do. This door is going to... Oh yeah, so this has nothing to do with the door yet, right? We just named it raise door in a timeline called open door. All right, X that out. We don't need to save it. But what did I do? I created this raise door track. Okay. Well, what color is the output? It's green. What color is the output of the alpha? Green. Notice the values that we did. Remember when we said when alpha was 1, it actually raised the door fully? Remember the values we just created to raise the door? It goes from 0 to 1, linearly, constantly. Okay, so what this is going to do, this thing is going to play for 1 second. And every event tick, every update, every screen update, it's going to go in here and set the relative location of this door. And it's going to start at 00200, and it will keep going for a second, linearly interpolating. You remember that word, linearly interpolating, lerp, through these two, and the value of that alpha is going to be based on this graph here. So at time 0.5 seconds, the value is going to be 0.5. All right, let's go ahead and see if that works. Play it. There it goes. Now, of course, it jumps back down. Well, why does it jump back down and why does it jump back up? It seems to want to work once and then not work the rest of the times. Okay, and I know exactly why. So let's just make sure you have this much. You have this timeline. You linearly interpolate. Okay, now, because I think what we should do is when it goes up, Sorry, there's a billion things. Oh, I know what we want to do. We want to actually do the same thing for ending overlap, okay? When we end overlap, let's go ahead. We're not going to do this. We can get rid of all of this. We're going to drag right to reverse. When we end overlap, we are going to reverse. Right? So we're now bypassing just setting it down. And the reason why we're going to go to reverse is because wherever that is in the animation, it will reverse. Now, theoretically, if we go in, go in, go in, why? Oh, but now why is it not raising all the way up? Well, it's not raising all the way up because remember, you guys are like, Hegney, even I knew that would happen. We didn't do the branch. We do have to go through the branch to make sure that it's us who's leaving it, because by bypassing that branch, the door leaving its own box was triggering the reverse. Okay, here we go. Now we're going to set that to reverse from the branch, compile that, save it. Let's go ahead, play that. It's going to go all the way up, and when we leave, no matter where we go, this is always going to work. Oh, this is nice. This is really nice. I'm actually quite happy that this is working as easily as I thought it would. Okay. Now, there's some other things we might want to do. Actually, I'm going to pretty this up now. We actually don't need this anymore. I'm going to delete that. I'm probably going to move this between the two. Okay. And the last thing I'm going to want to do is actually create a variable for the vector. And the variable I'm going to have is, I'm going to create two variables. You know, I'm going to do this in the next video because let's go ahead and stop on a good note. I'm going to delete this comment. I'm going to encapsulate all of this together and kind of just pretty this all up. There we go. Because this open door driver is going to run it. Oh, you know what? I will show one last thing because I kind of don't like this being so constant. I'm going to right-click these little nodes and click them to auto. And that's going to ease in and ease out the animation. So now it's going to start off slow, get fast, and then end slowly. Now that might actually be a little bit more believable. It's not noticeable that much, actually, because we're so close to it. But if we were further away from it, it would actually make a lot more sense. All right, in the next video, we are going to learn how to make this even smarter using vector variables.